right, page 55 in your textbooks. Page 55, you had at the bottom of the page the review, numbers 1 through 13 odd. Again, just some routine review for us. We want to keep our basic skills sharp as we progress through rational expressions, and then just 2 actual fraction problems. And that was those were number 35 and 37. Back on page 48, we'll get to those in a moment. But first, we'll take a look at the 1 through 13 odd. There they are. On page 55. Okay, 35 and 37 is up at the top. Excelente. All right. Number 1, double distribution. What'd you get for your answer, Maddie? Very good. So, again, that was x cubed, positive 7x squared, positive 17x, positive 14. Number 3, double distribution again, but this time we got to be careful how we lined up like terms. There were gaps and all kinds of nonsense. Ideally, putting our answer in descending order. Let's see if Kendall did that.
3x to the 5th, positive 0x to the 4th, positive x cubed, minus 13x squared, minus 4x plus 13.
All right, and do we have to say plus 0x to the 4th? No, but it's not a bad strategy for keeping things lined up if you really want the lining up, or you just kind of manage it. But good job. 3x to the 5th plus x cubed minus 13x squared, negative 4x, positive 13. Number 5, dividing by a monomial, sign number letter 3 times. Remembering, like I briefly forgot yesterday, subtracting the exponents. And by the way, that was not my only mistake yesterday. That same problem where I accidentally divided the exponents, there was a b cubed that had moved to the numerator. And I didn't remember to say that b didn't equal 0. And none of you caught it. But Gavin caught it. And Gavin emailed it in. And so I told his mom to tell him that that was excellent. I was hoping someone would catch that. And I'm proud of him for paying attention. So anyway, y'all help me out now, okay? Catch these mistakes that I make every now and then. But number 5, Michael didn't make mistakes on this one. So Michael, give us your answer.
I didn't.
You didn't.
Okay, negative 15a squared b plus 21a to the 4th, 3 to the 4th, plus 4a to the 13th, 3 to the 6th.
See? I told you didn't. I just checked your answers a minute ago, right? Negative 15a squared b, positive 21a to the 4th, b to the 4th, positive 4, a to the 13th, b to the 6th. Number 7, we'd love to use synthetic division, but we can't. We have to do it long division. Genesis did long division. What'd you get for your long answer?
1x cubed plus 3x squared minus 1x.
Perfect. 1x cubed, positive 3x squared, negative 1x, negative 3. Number 9, we're factoring via backwards FOIL. And, I mean, the start of the backwards FOIL is easy, right? Class x squared splits into x and x. Signs are going to be different, one positive, one negative, and like 104. Like, I didn't memorize that on any of my times tables. So maybe we factor up. I mean, obviously 1 and 104 isn't going to work. What about 2 times 52? No, does 3 go in? No, remember the sum would have to add up to something divisible by 3, and 5, which is the sum, isn't divisible by 3. I know 4 goes in. 4 times... You have a calculator. 26. Good. You didn't need a calculator. That doesn't get, what's my target area? A positive 5. That's what we're shooting for, is a positive 5x middle term. So that doesn't work. 5 obviously doesn't go in. 6 won't go in because 3 didn't work. 7? I don't even know. There's not a rule for that. Does 7 go in evenly? No. 1 with 3, no. Okay. Does 8 go in?
Yes. 13.
8 times 13. There it is. But we want the positive to be the 13 and the negative to be the 8. Again, sometimes that's just what you're stuck doing. A calculator does help to make it a little bit quicker, though. How many got that answer? X positive 13 times x negative 8. Questions. Stick with it. Test it till the iterator works. Number 11, a pair of conjugates in our answer. And Abby, what did you get for your sum and difference?
W positive 9 and W negative 9.
W positive 9, W negative 9. Would that W negative 9 factor a second time?
No.
No, because it's just a W, right? Not a W squared or anything like that. Number 13, x to the 5th minus 1. Not a difference of squares, but if we rewrote the 1, Brandon, as 1 to the 5th, we would have a difference of the same odd powers, right? Which would factor into a Binomial times a polynomial. How many terms in the polynomial, by the way? 5, because we have a 5th power. What was your answer?
X minus 1 times x to the 4th positive x cubed positive x squared positive x positive 1.
There we go. X negative 1 is the binomial, then x to the 4th, positive x cubed, positive x squared, positive x, positive 1. Anyone perfect? 7 for 7 on this part of the homework. All right, excellent. Questions at all? Flip back then to page 48. The sound of a calculator falling. Hope that wasn't a TI-30XA. That would be sit unto death as the Bible speaks. Oh, if it's a Casio, I don't care if you drop it.
Nah, it's
the TI-30XA. All right, let's take a look at number 35. It's a division problem, but do we ever really divide fractions, Audrey? We multiply by the reciprocal. So Audrey, on number 35, I'm going to copy down the r minus 4 over r positive 6. I'll even group these binomials because they don't factor. But instead of putting a division sign, I'm going to put raised up for multiplication. And then I'm going to take what was the denominator, r squared minus 3r minus 54. I'm going to move it up and I'm going to factor it in one step to get
r plus 18 minus 3.
Does the outer inner give you the negative 3r we were shooting for, though? No. So the negative 3r, no. So apparently it's not 18 and 3. We might take a little hint from what's over here. Let's try a 6. What 6 times what would give me that negative 54 we were shooting for? 6 times 9, and that would give me that outer inner. So again, we can cheat the system a little, and thank you, Audrey, for doing that to help me use that example. She did that on purpose. She's like, I really know he wants to point that out, so I'll help him a little bit. There we go. So there's our factors. And then on the denominator, it started us up at the numerator with the r to the 4th minus 256. We move it down, and that's a difference of squares. What do we get?
R plus 4, r minus 4.
Well, initially, you should have got an r squared plus 16, r squared minus 16.
Yeah.
Right? And then we factor the r squared minus 16 into...
R plus 4, r minus 4.
There we go. But we're going to still have the r squared plus 16. How many you're factoring? Your initial step, flipping, factoring, everything good to go. Any questions on this? Now comes the... Was that a question or a late hand that you got it?
That was a late hand.
Okay, just checking to make sure. You don't want to miss a question. All right, so now, Audrey, now that we've got it factored properly, right? The sum and difference, difference of squares, another sum and difference, that 4th power, our clue that that was possible. Now what do we do?
We can cancel the r minus 4s and the r plus 6.
And so our answer is going to be?
R minus 9 over r squared plus 16. Where r can't buy.
And the r plus 4, don't lose that one. All right?
R can't be 4, 9.
Good. This here can't be 9 because that was originally denominator.
Or negative 6.
Negative 6. How many have this answer, this final answer there? Of course, Audrey, we worked our way there. All right, those who did it, questions? Any questions on that division? All right, let's take a look at number 37. Again, we're going to leave the x negative 10, x positive 13. Don't flip the fraction before the division sign, but rather the one after as we multiply class by the reciprocal, right? And of course, when you're multiplying fractions or dividing, which turns into multiplication, any polynomials we see, class, we want to try to factor because we can only cancel factors, we can never cancel terms. And again, one of the nice things about multiplication, which is what this ended up being, we don't have to have a common denominator. We do have to have a common denominator, class, if we are adding or subtracting. But not with multiplication division. It's great. Kendall, let me come over to you here on 37. We're going to flip it, right? So the r squared plus 15x plus, or x squared plus 15x plus 26 moves up. How would I backwards FOIL that?
X plus 2 and x plus 13.
Good, in case we needed a little help, the 13 was here, but really, I mean, 26, it's either 1 and 26 or 2 and 13. So that took the suspense out. Then we move down. I'm going to go ahead and write it for just a moment. X cubed minus 1,000. Kendall, what is that?
It's a difference of cubes.
It is a difference of cubes because we know that 1,000, Kendall, is
10 cubes.
10 cubed. And a difference of cubes can factor into
A binomial times a trinomial.
all right, the binomial would be,
X minus 10.
and the trinomial.
X squared minus 10x plus 100.
One small edit, anyone?
It's a positive.
Right, so when you've got the negative here, remember all positive. And if it's positive here, then we have to alternate. So just that one little edit there, and then from there, Kendall.
You can cancel the x minus 10x and the x plus 50x.
And our answer?
X plus 2 over x squared positive 10x positive 100.
Where?
X cannot equal 10, negative 15, and negative 2.
Perfect. How many had this answer? For number 37. And other than the negative sign?
Yeah.
All right, good. Questions? Questions on this? All right, take a look at number 40 if you would, please. Number 40. And again, the first fraction, we know we're not going to flip it. How do I factor that first numerator? Maddie, what do you think? Because we got that a to the 4th, right? It's a trinomial. So we're going to try to backwards split. How do we split a to the 4th? Right, a squared. What about the signs? How about the 5? 1 and 5. Can either of these factor further, class? Yes, which one, Maddie? The a squared minus 1 factors again now into, there we go, just for you, Michael, a negative 1, a positive 1. What about that first denominator, Genesis? We've got an a to the 4th negative 4a squared negative 5. How would we backwards FOIL that?
A squared plus and minus 5 for negative and 1.
There we go. So the outer inner gives us the negative 4a squared. Can I further factor either one of these, class? No. Remember, a sum of squares does not factor. We're going to have to leave that just like it is. Then it says divided by, class. We're not going to put that. We're going to put multiplication times raised dot. And then we're going to flip into the numerator what polynomial? Michael?
A plus 1, a minus 1. Oh.
Well, initially it's
A squared minus 2.
the a squared minus 2. And Michael, you said we can factor that?
No.
No. Upon further review, it is unfactorable. Yeah, if it were a squared minus 1, we got that a plus 1, a minus 1. But we're just going to have to do what with it since it doesn't factor, class? Group it. Oh, well. All right, and then for the denominator, we're going to move down the a to the 4th minus 3a squared plus 2. That looks like it could backwards FOIL, Abby.
Into a squared minus 2, a squared minus 1.
All right, so a squared, both signs, yes, will be negative, and 1 and 2, yep, all right, that works. Where we could factor a little bit further here, Brandon.
A squared minus 1, 2. Yeah. A plus 1, a minus 1.
All right, so there's all of our factoring. Notice not as factored down as we're used to, but that's okay. We'll keep on rolling here. Now what do we need to do, Audrey?
Cancel stuff.
Cancel stuff. What cancels?
The a minus 1s, the a plus 1s, the a squared minus 2s, and the a squared minus 5s.
So what's left?
1 over a squared plus 1.
Good. 1 over a squared plus 1. Good. Remember, if the entire numerator is gone, don't forget to put the 1. That's one of the reasons I wanted to look at this. Now, here's where it gets interesting. Audrey, we canceled away an a plus 1, so we need to say that a cannot equal negative 1. We also canceled away the a negative 1, so we need to say that a cannot equal, and we could just say positive negative 1 in a sense, couldn't we? But what about here, where we canceled away an a squared minus 2? We're going to need to say, class, that a squared minus 2 can't be 0, right? But when I move the 2 over, it's not that a can't be 2, class. It's that a squared can't be 2. Quick flashback to Algebra 1. How would I get just plain old a instead of a squared? I could take the square root of both sides. And so I can also say that a cannot equal positive negative square root of 2. Remember, there's 2 square roots of every number, one positive, one negative. Do you remember that? So with this one, the a squared minus 5, again, to set it unequal to 0, class would initially give me that a squared cannot equal 5. So therefore, I have to take the square root, and we'll say that a cannot equal positive negative square root of 5. Does that make sense? And is that all the excluded values? I got this denominator, this denominator, this denominator, this denominator. This was an original denominator. I already canceled it though, right? So I don't have any uncanceled former denominators to worry about. And there's my answer. We haven't dealt with anything like this before. We end up taking a square root. But it leads us into what we're going to get into tomorrow, where we begin talking about radical expressions starting tomorrow. Questions on this though? Questions on that? All right. Next thing in your notes, complex fractions. Complex fractions. By definition, a complex fraction is simply a fraction with fractions in it. A complex fraction is a fraction with fractions in it. Complex fraction is simply a fraction with fractions in it. For instance, you might have seen something like this when you were in elementary school. Probably if it was elementary, it would have been like 6th grade. I don't think they would have thrown complex fractions at you until about 6th grade, maybe even junior high. But when you were learning this, whether it was late elementary or junior high, your teacher should have told you that a fraction bar means division. And therefore, a complex fraction really is just a division problem. If you write that down, complex fraction is simply a division problem. A complex fraction is just a division problem. It literally means the same thing as 2/3 divided by 4. These are equivalent expressions. It's just this one isn't side by side, it's straight up and down. Does that make sense? But here's the key. The top is the one before the division. You read it down. 2/3 divided by 4. So it's important to know that the denominator is what is technically after the division sign. Because we never really divide fractions, class. We multiply by the reciprocal, okay? So when it says 2/3 divided by 4, I can change that into 2/3 class times 1/4. Though we don't use the x, we use the raised dot. Right, 2/3 times 1/4, right? And then we just solve like we normally would, right? We'll cancel the 2 and the 4 to get 1 and 2. We'll multiply across to get 1/6. That's it. So really, this is the same thing we were doing yesterday. They're just going to be written differently. Does that make sense? Instead of being written with a division sign, they're going to be written on top of each other. But it's not a new concept. So same's on the third verse, right? You could say. So write this down if you would. A over B over x over AB. A over B over x over AB. What kind of fraction is this, class? Complex fraction. A complex fraction is just a division problem. So if it's a division problem, then we know we're really going to by the reciprocal. There we go. Brandon, we're going to multiply by the reciprocal. How should I rewrite this so instead of a complex fraction, division problem, it's a multiplication problem? Audrey?
A over B times AB over x.
How many thinking the same thing Audrey said? Any questions on what we just did there? And now we do like we always would with any multiplication problem. We try to cancel stuff, class.
B.
The B's cancel, and that leaves us, oh, do the A's cancel? No, they're next to each other. So what do we get for our answer then, Genesis? A squared over x, and since the B canceled away, we need to say that. And then notice, it wasn't just a B in this denominator, there was an A that's no longer in a denominator, so we also need to specify that A cannot equal 0. And there's my answer. Questions on this? Do you see how it's the same thing we did yesterday, just stacked instead of next to each other? Write this one down now if you would. a plus b over 2 all over a squared minus b squared over 6a. What is this thing, class? Complex fraction. Thank you, Brandon. All of you are allowed to answer, not just Brandon. And though I do appreciate it, Brandon. And if it's a complex fraction class, then really it's just a division problem. But we don't divide fractions, class. We multiply by the reciprocal. So how should I rewrite this as a multiplication problem then? Michael?
A plus b over 2 times 6a over a plus b, a minus b.
Good, and I like that he factored rather than taking the time to write a squared minus b squared. Excellent. I like the lazy way you are thinking. And I suppose we should go ahead and group the a plus b as a formality, but we see that what's going to happen next, Michael?
A plus b is going to cancel.
And anything else?
2 and 2.
2 and 2 cancel to give me
1 and 3.
1 and 3. And so my answer,
Is going to be 3a over a minus b.
any excluded values?
Yes. A minus b can't equal 0.
Well, a plus b can't equal 0, right?
Yeah.
Because we cancel the a plus b, though we usually move the b over as a,
Reciprocal.
well, inverse, so we would say a can't equal
Negative b.
negative b. There we go. And then there's one more excluded value.
3a.
Or just a, right? The a specifically that's right here also can't equal 0. By the way, it wouldn't be wrong, I don't suppose, to say a plus b can't equal 0, but I prefer the a can't equal negative b along with the a cannot equal 0. Questions on this? How many, as Michael was working through it, you're right there with them, you're thinking the same thing. Does it worry you that you think the same way Michael does? Okay. Questions on this? All right, let me give you a couple problems to practice there at your seats. I'm going to start with a review of what we were doing more yesterday, and I'll give you a complex fraction here in a second. Let's start with a more normal-ish one. X to the 4th, negative 8x, over x squared, negative 4x, negative 5, divided by x cubed, negative x squared, negative 2x, all over x squared, positive 2x, positive 1, times 2x, negative 10, all over 4x squared, positive 8x, positive 16. And I'll give you a complex fraction in a second. How many of you, as I was writing it down, changed what you wrote down compared to what I wrote down? A couple of you, good. Good. How many were literal and said, he said write this down, and I am an obedient, godly young person, unlike those other people who are lazy? Brandon shooting for teacher's pet over here. The rest of y'all like, I know he said that, but I know what he really meant. That's like those speed limit signs. Speed limit 35. No, I know they really mean 53. They just got the numbers backwards. Audrey's taking notes if we just nodded towards Dad. What's the first thing we always check for when we factor?
Common factors.
Common factors. Hopefully you caught a couple of common factors. To be mathematically accurate, a few common factors. A couple's 2, a few is 3. Okay, my bad. A scant number of common factors. Abby's finished. Brandon's like, meh, 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 meh. He's working so hard for teacher's pet, and Abby's just like, I'm gonna finish super fast. It's like picking on Brandon. I'm so used to picking on Brecken. Brandon starts with the same 2 letters, so. Got a little name drop there and see if Brecken woke up while he was watching the video. Michael's finished. Audrey's finished. Mama Maddie's finished. Janice is finished. Brandon's finished. Are you just keeping the pencil up? Okay. All right, there we go. Kevin's finished. All right, let's take a look at these. First class pull out, X. And what it's going to leave you with initially is going to be X cubed minus 8, where we know that 8 is 2 cubes. So we have a difference of which factors into a
Binomial times a trinomial.
binomial times a trinomial. So this is what our numerator is going to become. The binomial, of course, should be an x minus 2. X squared, x gone. 2 gone, 2 to the first 2 squared. Here's the negative, so these can all be positives. And then down here, of course, just backwards. FOIL, and Kendall, what do we get?
X plus 1, x minus 5.
All right, then we're going to multiply by the reciprocal. And so I'm going to take this x squared plus 2x plus 1. I'm going to put that here, Maddie, factored as... I'm sorry?
X plus 1.
Okay. All right, and then we're going to move this down, but the first thing we're going to have to do, class, is pull out another x, which is going to leave us with initially, Michael.
It's gonna initially, hold on, I gotta think. X plus 2.
Well, initially meaning the first thing we get when we pull out the x.
Oh, x squared minus x minus 2.
There we go. And then we're going to keep the x, and we're going to backwards FOIL the trinomial.
X minus 2x plus 1.
There we go. And then this, we're not going to flip anything. It's already multiplication, so don't flip this. We're just going to pull out here Genesis A to get, and then in the denominator, we need to start, oh, there were 4 common factors. I missed that one. There is a common factor here. We can pull, Abby, a
2.
I could do better than a
4.
2. I can pull a 4 out to initially leave me with.
X squared positive 2x positive 4.
And then we could try to backwards FOIL that, but it isn't gonna backwards FOIL, is it? So we're just gonna have to leave the x squared plus 2x plus 4, which doesn't break my heart that it doesn't backwards FOIL, Brandon, because
You can cancel it.
I can cancel with this big old trinomial. So I'm actually just fine with it not factoring further. What else can we cancel, Brandon?
All the x plus 1s.
All the x plus 1s. There's one here with one here, and then these two cancel with each other.
X minus 5.
X minus 5s cancel.
X minus 2.
X minus 2s cancel.
X's.
The x's cancel.
And then
And the 2 cancels out of the 2 and 4 to give me
1 and 2.
1 and 2. And I don't know if there's anything left to cancel, so our answer is.
1/2.
And again, the book would perhaps argue that there's a lot of excluded values, but all of them involve an x that doesn't exist anymore, so I'm fine with just leaving a half. How many got a half for this one? It's a really crazy way of saying half, you know? There's pizza sitting there on the table. Can I have half of that? Can I have x to the 4th minus x? Anyway, but technically that's what all this equals, right? This is a fancy way of saying 1/2. Anyway, you'd be a nerd though if you did it that way, so don't do it that way. Questions? How many got the 1/2 again? Checking for hands. All right. Questions on the factoring, perhaps? How many fell into the trap of flipping this one? Anyone do that? Okay, good. People forget common factors, maybe? The problem? Tried to factor this without the common factor coming out.
I missed some of that.
That was the thing that got you. Okay, give me some feedback. What was it that tripped us up? You have no idea? It's not a good sign. It means we don't learn from it if we don't know what tripped us up.
I did a PST on that one.
Right here, you turn to x plus 1 squared?
No,
This one.
the.
Oh, okay, so same thing, basically kind of the same thing as her. You tried to factor it when it really didn't factor. So you had this still in the top, and then all kinds of whatever down in the bottom still. Okay, all right, good. Anyone else feedback? What it was that got us if we didn't get it?
I didn't cancel the x plus 1s.
Just forgot to cancel one of the x plus 1s. Okay, all right, anyone else? All right, let's take a look at this one here. And I think Brandon is where we left off. So we'll go to Audrey. How should I rewrite this thing?
8 plus 1 times a minus 3
A plus 1 times a minus 3, okay?
over a cubed b
Okay.
times ab squared over a plus 3a minus 3.
How many, your initial step was the same? All right, well, it looks like everyone perfect. Then from there, Maddie. All right, and what's our answer going to become? Where and there we go, perfect. How many got the same answer on the second one? Are there any questions on complex fractions, multiplying fractions, dividing fractions? Any questions on any of this? Going once on questions. Going twice on questions. Cleared your desk except for a blank sheet of paper and a pencil and a calculator if it makes you feel better. Sheet of paper, pencil, calculator, everything else away. First one I say at the top of your paper, along with today's date, which is 9/15/21. 9/15/21. The arithmetic sequence there is adding 6 from one number to the next, right? 9/15/21. Nerd. Okay. 9, 15, 21 today's date. This is quiz 7. Quiz 7. Let's take a look at the quiz together very quickly. The numbers 1 through 4, short answer, write the answer. Numbers 5 through 10, you're multiplying, dividing, depending on, make sure you don't forget those excluded values with your answers. All right, you may begin. And if you're watching on YouTube, this is the end of the lesson. There is also no homework this evening, so we'll end the lesson here. Do well.